Good morning everyone. Here we were studying about the basics of the system programming, in which today we will see about the intermediate representation of a program. So if you see at the front end, there will be the source program. So front end will perform analysis of a source program, and that will results in a intermediate representation. And at the output side, if you see, you will get the target program. So we can say at the back end, second pass will read and analyze the intermediate representation instead of the source program, because now it is having जो front end है, it is giving result in the intermediate representation. So that can be used by the back end, and it will perform synthesis of a target program. And front end, back end need not reside at the same time in a memory, so memory requirement is reduced. It is the advantages of the intermediate representation. क्योंकि at the same time हम दोनों use नहीं कर रहे, we are using only one, so there you will require less memory. After that, you can see here about the assembler, pass assembler. So we can say here elements of the assembly language. So if we are supposed to use the assembly language, what we are saying, machine and assembly language both are the low level languages, since the coding for a problem is at individual instruction level. So we can say assembly language is a machine dependent, and it differs from computer to computer. So if we are supposed to write a program in assembly language, that will be more convenient than if we are writing the program in the machine language. Instead of the binary sequence in the machine language, we can write here the program in the form of symbolic instructions. So we can say assembly program is written using a symbol that we can say as a mnemonic operation codes. First one. After that, we are saying assembly program is more readable. It is difficult to understand and develop a program using a machine language. So we can use assembly language, but it is a machine dependent. And here we are supposed to convert assembly program into a machine code before a execution. So you will require a assembler. Assembler मतलब क्या होता है? It is a translator. So it can convert input in the form of assembly language program, and you will get the output that will be in the form of machine code. So we are using here the assembler to convert the assembly language program into a machine code. After that, you can see here we are using the symbolic operands. We are supposed to use their data declaration. So we can say elements of the assembly language provide three basic features. These are mnemonic operation code, symbolic operand, and data declaration. Assembly language statement. Here, when we are supposed to write the program, at that time assembly language statement will be of imperative statement or a declaration or the assembler directives. So we can see here firstly instruction format. You can see here the sign, opcode, which will require 2 digit, register operand 1 digit, memory operand which will require 3 digit. So we can say when we are supposed to write the assembly language program, at that time the machine instruction format will be like this. Here opcode will require 2 digit, memory operand 3 digit, and sign and the register operand will require 1 digit. Now we can see here about all these statements one by one. So when we are supposed to write the program, at that time what we are saying, instruction in the assembly language program should have some format. Label, it can be optional. If you want to write for the understanding, you can write, otherwise skip. But it will require opcode and the operand compulsory. So opcode means what? Which we can say as the symbolic operation, or we can say that as a storage specification. And operate, it is we are using for a memory, or we can use for the CPU register. So these can be number of operands in an instruction. So here we can see all the statements. Firstly, we will see about the imperative statement. So the statement which indicate an action to be performed during execution of a assembled program. So these are the executive statement, and here each imperative statement will indicate action to be taken during a execution of the program. So we are supposed to translate each imperative statement into a machine instruction. So after that we can see about the declaration statement. Declaration means what? The declaration statement are those statements which we can use for reserving the memory for a variable. So we can specify the initial value of a variable. And here when we will require the declaration statement, it have to follow some syntax. You can see here the syntax. You will require label. DS means what? Declaration statement. And after that you can write less than, constant, greater than. In between you are supposed to write the constant which will specify the size of memory that you are supposed to make reserve. Because declaration statement से हम क्या कर रहे हैं? We are using to reserve the memory for a variable. So this is its syntax, or we can write another way. You can see in the next syntax, label, DC, single quote, less than, value, greater than. In between that you can write. So we can say here DC means what? Declare constant, and DS means what? Which we are using for declare storage. Declaration statement में we can use two syntax. एक तो है हम जो यूज़ कर रहे हैं for the declare storage, DS, label DS constant, and another we can use as a declare constant. So we can say DS statement can be used for reserving block of memory for a variable, and DC statement can be used for reserving one word of a memory for a variable. So here you can see the example 1 DC 1, because we are using only one word, and if we are using the data storage, declare storage, we can say we can reserve block of memory. So A DS 100, because we can store that much memory here. So you can see here now the assemblers. So here we will see about the literals and the constants. So literal is nothing but it is a immediate operand which will appearing in a statement. If we will see any statement in C language, if we are writing x equal to y plus 5, what we can say? In this statement we will get their constant value 5. क्योंकि हम क्या लिख रहे हैं x इक्वल टू वाई प्लस 5, तो 5 जो है कांस्टेंट है, x and y these are the variables, so we can say that constant as a literal. Please try to understand. You can see here the example 5 dc 5 because it is the constant value, so we can say that as a literal. Literal is a immediate operand which you will get in the statement. So the value 5 is a constant, so we can say that as a literal. So we can say about a literal is operand which will have the syntax like equal to, you can see what will be the syntax in single quote value. Its location cannot be specified in assembly program, is not known to assembly language. So here we can say its value, literal's value cannot change during the execution of program because we are saying it is a constant. So we can say literal will appear as a part of instruction, and literal is more safe and it is protected than a constant because we are saying we cannot change the literal during the program execution. Now we can see about the constant. So you can see here it's a value which we can change during a execution. So it is the difference between a literal and a constant. Now we are supposed to study about the assembly directives. Here you can see they instruct the assembler to perform certain actions during the assembly of a program. So if we are saying about the assembly directive, there are 5 assembly directive we can use to write the program. These are nothing but start, end, origin, equate means EQU and the LTORG. We will see all these. So start, you can see if we are writing like that, start 500. What we can say, the first word of a target program to be generated by the assembler, which should be placed in a memory word with a 500. मतलब जो हमारे पास 500 memory है, we can start the program with the address 500. And end, obviously, as the name define, it will end the source program. Now you can see here about the origin. Origin means what? Which will tell line counter to be set to the specific address, or you can say to the operand. So here if we are having origin 100, or we can write origin loop plus 20. It means what? It will tell that counter, line counter, LC matlab line counter, to be set to a specific address 100 or to the specific address which now it is having, and it will add plus 20 to that. So here we can say about the equate. So EQU, it is nothing but it is the statement which is having the syntax like symbol EQU address specification. It means we can say address specifications can be operand specification or it can be a constant. So if we are writing any equation, like if we are writing any program in which we are writing the instruction back EQU loop, मतलब क्या है? Back is set to the address of loop. So by using that, what we can do, जो अभी हमारे पास डेटा है, we can give that to the operand specification. So you can see here the symbol EQU address space, it will give the same address to variables which are associated. Now LTORG. It is the statement which will permits the programmer to specify where literals should be placed. And by every default assembler place literal after end. And at every ltrog and at end statement, assembler allocates memory to the literals in literal pool. So you can say here, pool contains all the literals which we are supposed to use in a program and since last ltorg. So if we are talking about the ltorg, we can say here you will require at every ltorg statement memory should be allocated to the literals of the current pool of the literals, because it is giving the permission to a programmer to specify where literals should be placed. Thank you. Remaining we will see in the next class.